Good morning, grade 7s. My name is Siseko Ntuli. I'm here to present transformation geometry, but my focus today, it will be only on enlargement and reduction. Hoping that, guys, we are going to have a wonderful day. Again, it's very easy topic and nice. So let us get to it. So as I've said, that we are going to be focusing on transformation geometry, but only on doing enlargement and reduction. My lesson outline is as follows. First of all, guys, in every topic, when we are about to indulge ourselves in a topic or a new topic, we need to familiarize ourselves with the vocabulary that is used. So in this case, we will be familiarizing ourselves with the vocabulary that is used in enlargement and reduction. Also, we need to understand what resources must I have so that I can be able to do this topic or this part of transformation. And then we are also going to touch on demonstrations. We are going to do enlargement practically so. We are going to do reductions practically so. And then there will be a lot of exercises there and there so that we can be able to understand it thorough. Then the vocabulary that we are going to be faced with under this subtopic here, it will be, we are going to explain what is enlargement, what is reduction, what is meant when we say center of enlargement, factor of enlargement, factor of reduction. So those are some of the ways that we are going to come across a lot. So it is very vital and important for us, guys, that we understand what each word means so that whenever we read in a scenario, we are able to understand what does that mean so that when we understand it, it becomes easier for us to be able to do it. All right, then let us get to vocabulary meaning. The first word there was enlargement. What does it mean when we say enlargement, or what does it mean? We say enlargement, a transformation of an object that maintains the shape but increases the size of the object. It maintains the shape. The shape, if it was a rectangle, it will still be a rectangle, but the size will not be the same as the object. So it means that that shape has been enlarged. Then reduction, what does it mean to say reduction? Reduction, we say a transformation of an object that maintains the shape but decreases the size of the object. This one, same applies to the first one, whereby we said if, for example, we are talking about a rectangle, now the shape will still be a rectangle, but it will be a decreased rectangle. The size won't be the same as the size of the object. Then the word center of enlargement, what does it mean? It means the point from which the enlargement takes place. The point from which the enlargement takes place. Then we have factor of enlargement. The number of times the object is enlarged. For example, by a factor of 2 means the length of the sides are doubled. Factor of reduction. The factor of reduction by which the factor by which the object is reduced. For example, by a factor half means the length of the sides are halved. Then we're going to talk about similar figures. What does it mean? When figures are enlarged or reduced, the enlarged or reduced image is similar to the original figure. It is similar, guys. Be careful there. It is similar, not the same. And if two or more figures are similar, this means that their corresponding angles are equal. Very important there, guys. It means that if two figures are similar, it means that their corresponding angles are equal. And also their corresponding sides are longer or shorter by the same scale factor. Right. The resources that we're going to be using this here, guys, will be our grid paper. We'll use a grid paper. Here is a grid paper. So we will be using a grid paper. Then we'll be using pencils. We'll be using pencils. And then we'll be using different colored markers. Different colored markers. So you may also have yourself those resources. Then here is a tip, guys. This one is very important, and we must know it, and we must always try by all means. You see, there are ways that I highlighted there in red. I want to emphasize that so that when we get into this information, when we try to do our activities practically, so we are able to understand what does it mean. First, here is tip number 1. When the scale factor is 1, image is the same size as the original shape. So please, when we get along into the activities, we're going to read and highlight what is important there for us, or what has been provided there for us, especially when it comes to scale factor. So tip number 1, when the scale factor is 1, image is the same size as the original shape. So the original shape might be having side length 5 and width of 10. So it means that if the scale factor is 1, there won't be any changes. They will be equal. And then when the scale factor is less than 1, the image is a reduction. So just know that we talk about a half, we talk about a third, we talk about a quarter, we talk about 2/3, we talk about a fifth, we talk about 3/8. So all those numbers are less than 1. So it means that we are talking about a reduction. So the object will be bigger than an image in this case, or the original shape will be bigger than the image because the scale factor is less than 1. For example, if the scale factor is half or 0.5, each side of the image is half the length of its corresponding side in the original figure. It means that it will be less. Right. Bullet number 3, when the scale factor is greater than 1. So here we talk about from 1,1, 1,2, 1,3, 1,4, up to 2, up to 3, up to 4. It means that the image is an enlargement. For example, if the scale factor is 2, each side of the image is double the length of its corresponding side in the original figure. So in this case, the image will be bigger than the original shape because the scale factor is greater than 1 or bigger than 1. Anything from 1,1 and above, it will mean that the image will be bigger than the original shape. Right. So I want to emphasize again there, guys. First of all, we said when the scale factor is 1, the image is the same size as the original shape. When the scale factor is less than 1, the image is a reduction, which means the image will be smaller than the original factor. The original shape. When the scale factor is greater than 1, it means that the image is an enlargement. Therefore, it means that the image will be bigger than the original shape. Right, let us do it practically. So after having that information, guys, let us try exercise number 1 and check whether we can be able to apply this theory into practice. Let us see, guys. The first one, bullet number 1 says to us, state whether the following scale factors will produce larger or smaller image. Number A, if the scale factor is 5, guys, will it produce a smaller image? Will it be a reduction, or will it be an enlargement? Remember, guys, let us go back. We say here, when the scale factor is greater than 1, so let us just check there, is greater than 1. our first activity there is giving us the scale factor is 5. So by so seeing that the scale factor is 5, it means that the image will be larger. In other words, it will be an enlargement. Therefore, we say it will produce a larger image. Number B, what happens now if the scale factor is 0.25? If the scale factor is 0.25, what happens? Is it bigger than 1? Is it less than 1? Remember guys, 0.25, it shows it is smaller than 1. So if it is smaller than 1, that means that it will produce a smaller image. There we go. It will produce a what? A smaller image. Because why? The scale factor, it is 0, it is less than 1. Therefore, it is 0.25. What happens when the scale factor is 1.2? Remember guys, 1.2 is bigger than 1. Therefore, by so seeing that this is bigger than 1, it says to us that it will produce a larger image. Why? Because the scale factor is bigger than 1. Anything from 1.1, 1.4, 1.7, 1.9, 2, 3.1, 6, up to infinity. The minute it is bigger than 1, it shows that it will produce a larger image. There we go. What happens if the scale factor it is 3/8? Now 3/8, it means that, remember guys, 3/8 is a fraction. Now 3/8 being a fraction means that a fraction, remember, it is part of a whole, or a part of something that is a whole. A whole is something that is 1 and more. So in this case, 3/8 is a fraction, and this fraction, it has got a numerator that is smaller than the denominator. So in this case, we don't have an improper fraction. It is a proper fraction. If it is a proper fraction, like in this case, it means that it is less than 1. The only fraction that is bigger than 1, it is an improper fraction, where the denominator is smaller than the numerator. So in this case, our numerator is bigger than the denominator. As we can see there, our numerator is 3, our denominator is 8. So if our numerator is smaller than the denominator, it means that it's a proper fraction, number 1. Number 2, being a proper fraction, it means that it is less than 1. All proper fractions are less than 1. Now, if it is less than 1, it means that it will produce a smaller image. It will definitely produce or give us a smaller image. Right. Now let us be more practical. In exercise 2 here, it says to us, if a circle has a radius of 10 centimeters and a second circle is drawn with a factor of half, what is the radius of the image B? Or what will the radius of the image be, or what is the radius of the image be? Now, let us just take a look. So here, guys, we are told that the original circle has a radius of 10 centimeters. The radius of the original circle is 10 centimeters. The original circle, now they are asking us what will be the radius of a smaller circle, or the image B, if the scale factor is half. Now we are given the scale factor is half. Now, if our scale factor is a half, then we want to find out the radius of the smaller circle. Remember, guys, when we are working with enlargement or reduction, we use only one sign. In this case, we'll always multiply with the given scale factor. In this case, the original has got 10 centimeters as its radius. So we're going to multiply this by a half. Remember again, Before we can even go further, we know that because the scale factor is less than 1. Now, if the scale factor is less than 1, it shows that it is going to produce a smaller image. Remember, we said that if the scale factor is less than 1, then it is a reduction. So we know that the information that we're going to get here, the radius of the original circle will be bigger than the radius of the smaller circle. Why? Because the scale factor is less than 1. So we'll say 10 multiplied by a half. Normally, to do this simpler for you guys, remember, you can put it as 10 out of 1 because the denominator of 10 there is 1 and multiply by a half. Therefore, we simplify 10 multiplied by 1 equals to 10. 1 multiplied by 2 equals to 2. Therefore, 10 divided by 2 equals to 5 centimeters. So that means the radius, so we are doing our conciliatory statement there. The radius of a smaller circle will be 5 centimeters. So will be 5 centimeters. And is it true that it is smaller than the radius of the original shape? Yes. Why? Because the radius of the original shape was 10 centimeters. We applied the scale factor of a half. We found that the radius of a smaller circle will be 5 centimeters, which will be less than or smaller than the radius of a image or a object or the original shape in this case. Now, therefore, our answer will be, as we have done it, 10 centimeters multiplied by a half, therefore will give us 5 centimeters. So yes, it is smaller. And it helps us to understand that what we spoke about when we said that if the scale factor is less than 1, then the result will be a smaller image. Let us look at bullet number 2 here, guys. It says, if the perimeter of a square is 12 centimeters and the scale factor of 2 is used, what will the perimeter of the image be? So guys, I'm going to give you like 5 minutes to think around this, check in the scale factor, and then we'll do it together after that 5 minutes, guys. Just think back what we spoke about when we said if the scale factor is what happens? If the scale factor is what happens? So your 5 minutes begins now. All right, guys, your 5 minutes has lapsed. Let us see. Right, let us see what you have done, and we will compare your answers with what we will be doing together again, so that you can see if there are any mistakes that you have made and how we can correct them. Remember, guys, you are allowed to make those mistakes so that you can learn. As you make the mistake, you learn something new, that, okay, this is how I was supposed to have done it. My mistake is here. It's very, very encouraging that you do it. Do it first. See your mistakes. See where you went wrong, so that whenever we are doing it together, then you are able to notice where your mistakes were. Right, guys. Now, let us read again. It says the perimeter of a square is 12 centimeters, and the scale factor of 2 is used. Now, the scale factor of 2. First thing first there, guys, we can see the scale factor is 2. Now, the scale factor being 2, it means that the scale factor is bigger than 1. Now, if the scale factor is greater than or bigger than 1, then it means that our image will be an enlargement. So when they say what will the perimeter of the image be, our starting point would say the image will be an enlargement. It will be an enlargement. The image will be an enlargement. Why? Because the scale factor is bigger than 1. Now, the easier way, guys, that we can also use to memorize our calculations. Here I've provided you with something that may help you. First thing what you do, you take the size of the original shape, then you multiply this by scale factor always. And then your result will be an image. If you can memorize this, guys, it might also add to your mastering of the enlargement and reduction of transformations. Now, we take the size of the original shape, we multiply by a scale factor, and then the result will be our image. Sometimes our image will be enlargement, and sometimes our image will be a reduction. What will help us to determine whether it's an enlargement or reduction? It's going to be a scale factor. Our scale factor, if it is less than 1, we know that it is a reduction. If the scale factor is greater than 1, we know that it is a enlargement because it is greater than 1. So let us put this into practice. Now, the size of original shape, we were given that it is 12 centimeters. So that is the size of the original shape. Then we have to multiply this by the scale factor. You said the scale factor was how much? The scale factor was 2. So we're going to multiply this by 2. Then our results will be an image. How larger will the image be? So we'll take 12 centimeters multiplied by 2, which will give us 24 centimeters. Therefore, let us do our conciliatory statement. So the perimeter of an image will be 24 centimeters. The perimeter of an image will be 24 centimeters. Very interesting there, guys. The first thing that we did, we showed that we understand the topic there. We said the image will be an enlargement. That is the first point to take into consideration. The image will be an enlargement. Why? Because we have seen that the scale factor is greater than 1. Now we put our calculations, or the way in which we're going to calculate in a way of an equation there. We put our equation, we said, okay, how are we going to calculate it? We're going to take the size of the original shape. We will always take the size of the original shape and multiply that by a scale factor, irrespective whether it's enlargement or reduction. So this ratio, or I'm sorry, this equation that we just provided, guys, it works irrespective whether it's an enlargement or a reduction. When you are putting it down, said, okay, if I want to understand how much will the image be, I must take the size of the original shape and I must multiply this by a scale factor. It will give me the size of the image. So that's why I wrote the size of the original shape multiplied by scale factor, it is equals to the image. So like I said, guys, before, please, when you do this more and more, you discover ways in which you can be able to make it simple for you. So this is my way of making it simple for you guys. You can also devise your own way of how to make this simple and interesting and challenging. So This is how we can be able to master it through practice. Right. Now, here is our answer again, which is the same as the one that we just calculated there, which is 12 centimeters multiplied by 2, which is giving us 24 centimeters. Right? Now, let us move on, guys. Now, let us observe this. Exercise 3, it says, let us now do it practically, whereby we are now going to be using our graph papers. Remember, we have said that is one of the resources that we'll be using. So let us now take it into practice. Now, in this, it says, the rectangle has the following dimensions. It is 1 block high and 2 blocks wide. 1 block high and 2 blocks wide. Now, enlarge the shape by a scale factor of 2. Remember, guys, again, if the scale factor is 2, what will happen? What will happen to the original shape? Will it be a reduction? Will it be an enlargement? Yes, correct. It will be an enlargement. Why? Because the scale factor is bigger than 1. But here is the tip here. Remember, here you are not just focusing on one side thing. You are focusing on 2 sides. We've got the height there, and then we've got the width. So our height there, we were given that our height is 1 block, yes. And then our width is 2 blocks. Now, if we want to find the image or enlarge this shape, let us first put it the way it is here. So I'm just drawing it. This shape of us, it is 1 block high and 2 blocks wide. 2 blocks wide. So this is the shape. This is the shape that I'm talking about. Now, guys, we are told that this shape, it is 1 block high and 2 blocks wide. By our scale factor, let me just write here scale factor. Scale factor is 2. Remember again, guys, I said you take the size of the original shape, multiply it by the scale factor, it will give you the size of the image. Now let us look for the image. How much will it be? It is 1 block, so it will be size of the original 1 block multiplied by the scale factor, which is 2. It will be equal to the image. So 1 multiplied by 2 equals to 2. So our image will be 2 blocks high. Remember, we took the height. So here's that H is representing that I'm taking the height first. Therefore, the image will be 2 blocks high. 2 blocks high. There are my 2 blocks. So 1, 2. Right. And then the width here, it is 2 blocks. So the width here, it will be 2, which is the original multiplied by the scale factor. The scale factor is 2. Therefore, it will give me 4. So the width will be 4 blocks, which is 1, 2, 3, 4. Again, 1, 2, 3, 4. So my width will be 4 blocks wide. So let me just draw it. Let me use a ruler. Right, then 4 blocks wide, 4 blocks wide, and then 4 blocks wide, 4 blocks wide, and 2 blocks. Then we may color it. Right, there we are, guys. We managed to make it. Remember, we were told that the height was 1 block high. Take the size of the original shape, multiply it by the scale factor, then you will get the image. The image, this one will be our image. So it will be an enlargement. It will be larger, or rather say it will be an enlargement. If the scale factor is less than 1, remember guys, if it's less than 1, what will it be? It will be a is bigger than the denominator. I'm sorry, the minute the numerator is smaller than the denominator, it means that we are having a scale factor that is less than 1. Therefore, it will be a reduction. The image will be a reduction, meaning that the image will be smaller than the original shape. There we are. Now number 2, let us check number 2. It says here to us on number 2, on grid paper, enlarge the triangle below with a scale factor of 2. Now the scale factor of 2. Now we know, first thing that we need to just always remind ourselves is that if the scale factor is 2, is bigger than 1, it means that the image will be an enlargement. Now let us start. How are we going? I'm going to give you a tip here. My focus in most cases, guys, when we enlarge a triangle, I don't focus on this side. My focus will be on the height and the base. The height and the base of a triangle. I'm going to count the blocks so that I can be able to know that, okay, the original shape, it has got how many blocks, so that I can take those blocks and multiply them with a scale factor. Now here, let us take the base. The base is 1, 2, 3, 4 blocks, almost 4 because this one is not a full block, but we'll count it as full. So it will be 1, 2, 3, 4 blocks. Now it means that the image has the base is equals to 4. Now the height is equal, let's check the height, the number of blocks in the height, 1, 2, 3. So we'll say it is 3 blocks. Now if the height is 3 blocks and the base is 4 blocks, with both of them must be multiplied by the scale factor. Therefore, we can come this side and say, okay, base is equals to 4 blocks. Then we're going to multiply this by the scale factor of 2 because we were told that the scale factor was 2. Therefore, the image, the base of the image will be 8 blocks. 8 blocks. Now let us plot it. Let us do it practically. Now the base, let us just draw it next to this one. Let us start it here. You may start it anywhere you want, just don't make it touch this one. So I opted to start it here. So I'm counting 8 blocks. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So my base will end here. It will be 8 blocks, which is 1, 2, 3, 4, 5, 6, 7, 8. Now, my height, the original was let me write the height of the original was 3 blocks. Now we will take these 3 blocks, then multiply by the scale factor of 2. Therefore, the image height will be 6 blocks. Be there for blocks, guys. Now, my height, counting. So when I'm counting my height, I'm going to start here. 1, 2, 3, 4, 5, 6. Therefore, my height will end here. So it's 1, 2, 3, 4, 5, 6 blocks. Therefore, I join my points. I join my points to make an enlargement of the original shape. Then I join my points. Like I said, guys, when I was giving you a tip with a triangle, I'm not focusing on that last side. But I know that it's going to be easier for me to do it because I'm just going to join my points to form a triangle. So, there we are. So this one, remember guys, we said this one is the image. This one is an object, which is the original shape. So, yes, indeed, it is correct. Remember we said if the scale factor is greater than 1, then the image will be an enlargement. Isn't it an enlargement? Definitely it is an enlargement of a shape. So we've got an enlargement there. Now, again guys, tips here are very simple. Remember, always, when you are given the scale factor and the image, each side, identify how wide, how high, how long is each side, so that you can be able to apply the scale factor and get the image. Because again, when we are given the scale factor, you multiply the scale factor by all the sides. One side and this side and that side and that side, it will definitely give you the image of a new shape that you're supposed to enlarge or reduce, or do a reduction on that. Now let us check number 3. On grid paper, it says on grid paper, resize the following figure. Use scale factor of 0,5. So we've got a shape there like U. Right. First of all, let us identify the following. The scale factor, guys, it is 0,5. Now, if the scale factor is 0,5, meaning that the scale factor it is less than 1, the image will be what? Will it be an enlargement or a reduction? The scale factor is 0,5. Will it be an enlargement or a reduction? Yes, you are correct. It will be an reduction. It will be a reduction. Why? Yes, because the scale factor is less than 1. Now, if the scale factor is less than 1, we will definitely have a reduction. Now, what is also important here is that we have many sides. We've got this side, 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 and then this side. And then all these sides, although this side will be equal to this side, and this side will be equal to this side. This side is on its own, and this side is on its own. So let us try and work it out. How many sides do we have? Because this side and this side are equal. So, or we can just label them. I don't want to jump into something that later on might confuse you guys. So let us say here we have this side, we call it A, then this side we call it B, this side we call it C, this side we call it D, this side we call it E, this side we call it F, this side we call it G, this side we call it H. Now, A is equals to 2 blocks. B is equals to, let us count the number of blocks, 1, 2, 3, 4, 5 blocks. And then C is equals to, C is this one, 1, 2, 3, 4 blocks. And then D is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 blocks. D is equals to 5 blocks. And then E, remember E is the same as A, so it will be 2 blocks. And then F, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 blocks. It will be 7. FG, it will be 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks. And then H, 1, 2, 3, 4, 5, 6, 7. H is identical to F, so it will be 7 blocks. Right. After we have done that, what we can then do, guys, is to also remind yourself that we have, this is the size of the original shape. Now all these, we have to multiply them by our scale factor. Now our scale factor in this case is 0,5. So we'll say this is 2 multiplied by 0,5, and then 5 multiplied by 0,5. So we are looking for the size of the image. And then 4 multiplied by 0,5, and then 5 multiplied by 0,5, and then 2 multiplied by 0,5, 7 multiplied by 0,5, 8 multiplied by 0,5, 7 multiplied by 0,5. Right. Remember, guys, again, this 0,5 is written to us, given to us as a decimal fraction. Remember, 0,5 is equivalent to a half. So you would also be correct when you multiply this by a half, because 0,5 is equivalent to a half. So as a fraction, it is a half. As a decimal fraction, it is 0,5. Now, 2 multiplied by a half, or 2 multiplied by 0,5, half of 2 equals to 1. So our A will be 1 block. So I can do my illustration. I will do it this side. So my A here, I will put my A here of the image. It will be 1 block, which is going to be my A. Let me say A prime, because now this is a reduction. And then 5 multiplied by 0,5. 5 of half is going to be 2 and half, 2,5. Now, which means my B will be 2,5, because I took my B. 5 multiplied by 0,5 is going to be 2,5. So where is my B? B is this side. So I know that it's going to be 1, 2 and half. So my B will be here. So I can just do my dotted lines there, so that I will redraw it with my colored. 4 multiplied by 0,5. Half of 4 equals to 2. Therefore, my C is going to be 2. This was my B prime. So my C would be 1, 2. This C prime. Right, we move along. 5. D is 5. So 5 multiplied by half, or 0,5, is going to be 2,5 as well. So it goes up again. This is where my D prime will be. Then E, 2 multiplied by half. Half of 2 equals to 1. So my E will be 1 block. So E prime. Then F, 7,5. 7 multiplied by 0,5, I'm very sorry there. 7 multiplied by 0,5. Half of 7 is 3.5. It's going to be 3,5. So we're going to go 1, which is our F prime, 1, 2, it was 1, 2, 3, 4, 5, 6, 7. Yes, 1, 2, 3, 4, 5, 6, 7. Right. So it will be 1, 2, 3.5. So which will be our F prime. Right, and then we are looking for G, which was 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 multiplied by 0,5 will be 4. Half of 8 is going to be 4. So we'll count from here 1, 2, 3, 4. So this will be our G prime. So H, because H was equivalent to F. Remember, this was a half here. So H will also be similar to that. So if I'm joining them now and to draw and make this shape, let me put this point here where F ends, and then which means H will start here. Then I can join them together. That will be my first line. Then that will be my second line here. This one will also be my third line. Then I will be having this one and this one. And then I will be joining this one. Remember, this one was not, here was not a full part. It was only a semi part of half of the block. Then I will be joining this one. And also I will join this one. Therefore, I have my reduced image. So this was the object. This is the image. This is the image, guys. Now, when you see that, guys, just to do it quick again, A was 2 from the original shape. We multiply this by the scale factor of 0,5. Now, it became 1. Then we had only 1 block for A. Same applies to E, because A and E are identical, so it's one and the same. So this one and this one, we also managed to do them both. Again, C was on its own. So C was 4 blocks, 1, 2, 3, 4. When we apply the scale factor or multiply that by a scale factor of 0,5, then we have 2 blocks. So yes, we do have 1, 2 blocks. It covered 2 blocks. And then when it comes to D was 5, 1, 2, 3, 4, 5. And when we apply our scale factor, 5 multiplied by 0,5, it gives us 2,5. Therefore, we'll have 2,5. Therefore, you have 1, 2 full blocks and half block, because it's 0,5. Therefore, we are able to do all the points when we apply the scale factor there. And yes, it is correct, because our object is bigger than the image. Why? Because the scale factor was less than 1. And we know if the scale factor was less than 1, it means that the image will be smaller than the object. Right. So guys, let us move on to the last one here and see whether we can be able to do it again together. Now, number 4, it says on grid paper, resize the figure below. Use a scale factor of 1/3, 1/3. So, let us use this side. First of all, by observing, number 1, what is alarming or what is giving us heads up is the scale factor. The scale factor is 1/3, 1/3. So, if the scale factor is 1/3, it means that it is less than 1. It is less than 1. And if it is less than 1, it means that our image will be a reduction again. Why? Because the scale factor is less than 1. So if our scale factor is less than 1, forever we'll be encountering a reduction. Right. Now, we need to put the size. We need to label the sides of this shape. Right. Let us label this side as A, this side as B, this side as C, this one as D, this one as E, and this one as F. So if we have labeled the sides, it makes it simpler for us to be able to identify so that we can be able to calculate. Now, after having labeled the sides, we need to count the original A. It is 1, 2, 3, 4, 5, 6 blocks. So it will be 6. Then we're going to multiply by the scale factor of 1/3. So remember, I said if you are multiplying by a fraction, remember you also put this whole number as a fraction over 1 to make it simpler for you. And then B, therefore the image, let us just, I'm sorry guys there to confuse you, let us just go straight and so much solve it to find the image. So 6 multiplied by 1 will be 6. 1 multiplied by 3 will be 3. So we'll be having 6 out of 3 because 6 multiplied by 1 is 6, 1 multiplied by 3 is 6. 6 divided by 3 equals to 2. Or somebody just see 6 divided by 3 multiplied by 1. Still the same thing. So 6 divided by 3 equals to 2. So we know that the image, A image will be having 2 blocks. We may say, okay, this is where we're going to put the A of the image, which is going to be our A prime. So we can with a pencil highlight 2 blocks there and there. 2 blocks. Now, we move on to, let me erase this so that it cannot escalate it, cannot skip where it's supposed to be. So remember we said the A prime will be 2 blocks of the image. Let us find B. B was 1, 2, 3 blocks. So it will be 3 out of 1 multiplied by 1/3. So 3 by 1 is 3. 1 multiplied by 3 is also 3. So 3 out of 3 equals to 1. Therefore, B will be 1 block. So we'll put 1 block for B. It goes down. Let's say B prime. Now, C, 1, 2, 3. So C, because it is 3 as well as B, we know that it will be 1 block. So C, we can say 1 block. So let me write it underneath and I say C prime. And then D was 1, 2, 3 blocks. So D was 3. So we know also that D will be 1 because our calculations are the same as B, C, and D. They are 3 blocks each apart. So it will be also 1. So you'll see here is going to be D prime. Now we move to E. E, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our E is having 9. So we'll write it as 9 out of 1. Multiply by the scale factor. Always multiply by the scale factor, which will be equal to 9 multiplied by 1 equals to 9. 1 multiplied by 3 equals to 3. Therefore, remember this is a division line. 9 divided by 3 equals to 3. 9 goes into 3 times without leaving any remainder. So 9 will be, E will be 1, 2, 3 blocks going to the left. So this will be our E prime. Right, and then the last one, which is F. F is having 1, 2, 3, 4, 5, 6 blocks. Right, so F will be 6. Therefore, it's going to be 6 over 1 multiplied by a third, which will then be 6 multiplied by 1 is 6. Over 1 multiplied by 3 equals to 3. Therefore, 6 divided by 3 equals to 2. 3 goes into 6 2 times. So it will be 1, 2 blocks. Right. After having done that, then let us redraw the shape the way it is supposed to be. I'm going to go this direction, join those points, join this one, join this one as well, join this one, and then join this one, and then I get my full shape. I get my full shape, which is a reduction, as we have anticipated it to be because of the scale factor. The scale factor showed us that we are going to experience a reduction. Why? Because the image, the scale factor was less than 1. This one is the object, which is the original shape. This one is the image. So guys, what is most important here, guys, is that when we do the enlargement or the reductions, most of the time, it won't be normal shapes that we are used to. It may come in any form. Like you have seen when we started with a triangle. We started with a triangle, which is a shape that we are most familiar with. But then as we went along, we were using shapes that we are not familiar with. But the most important part there, I made them simpler for me to label them so that I can know which one to reduce or to, yes, in this case we were reducing, which one to reduce it with how much. So if I reduce it, I'm going to reduce it with how much, because I'm going to just apply my scale factor so that I know my reduction will be how much. So after having put them, or after having labeled them, then it made it simple for me to be able to redraw a reduction of a shape. There I do have it now, because I've got a reduction and I've got both my reduction. So you can see we started here with an image, where we were enlarging it. What showed that this is going to be an enlargement? Because the scale factor was greater than 1. If the scale factor is greater than 1, we know that we are going to be doing an enlargement, which means the image will be bigger than the object. Then we went along where we were now doing a reduction. A reduction, it is when the scale factor is less than 1. If the scale factor is less than 1, then we are going to encounter a reduction, which means the image will be smaller than the original object or the original shape. Remember guys, these alphabets were not given to us, so we needed to be creative there so that we can be able to simplify everything for us. And 2,5 is 2.5. So the full block, it does not mean that you will have a full block. It means that you're going to have a half of that block because it is a half. Therefore, we went on up until to this one. Again, because the scale factor was a third, we knew that our image will be a reduction. And if our image is a reduction, it means that it will be smaller than the original shape, or it will be smaller than the object. Right. Now, let us check this one. This one. Right. These shapes are given to us. The question says, look at the following rectangles and answer the questions below. A, we've got rectangle EFGH, which is the one in the middle. EFGH. Question number 1 says, how many times is FG? This one. Longer than BC, which is this one. How many times? So I'm going to put the equals to sign. Then we will then focus on rectangle JKLM, which is this one, JKLM. And then how many times is KL longer than BC? We are comparing. How many times is JK longer than AB? Right. So guys, here is the tip. Remember, we can see this shape in this because both these two shapes are compared to this one. So if these two shapes have been compared by this or are compared to this one, it means that there was a scale factor that was applied there. Now we need to ask ourselves what scale factor was applied, because these questions are asking us what scale factor was applied, though they don't put it out straight. So the first one, it says, how many times is FG longer than BC? How many times is FG longer than BC? So we're going to count 1, 2, 3. BC is having 3 blocks, but FG is having 1, 2, 3, 4, 5, 6. So how much was it multiplied by? From 3 to 6, it was multiplied by 2. So the FG is longer than BC by 2. The scale factor there is what is 2. We're looking for the scale factor, although they did not put it out there that the scale find the scale factor. How many times is EF longer than AB? EF longer than AB. They are equal. So the scale factor there was 1. Because anything when you multiply by 1 remains as is. I'm sure now you are getting where I'm going, guys. Now let us take a look at rectangle JKLM. How many times is KL longer than BC? BC 1, 2, 3, and then this one 1, 2, 3, 4, 5, 6. So the scale factor there again was how much? 2. because it's 1, 2, 3, 4, 5, 6 is the same as the length are the same as that one. Now, the length of this one and this one are the same, which is bigger than this one by a scale factor of 2. The last one, that says, how many times is JK longer than AB? Let us check. JK is 1, 2, 3, 4 blocks. 1, 2, 3, 4. And then AB, 1, 2. So the scale factor was how much? Was 2 as well. Because 2 multiplied by 2 will give you 4 blocks. So the scale factor they applied there was 2. So be careful there, guys. When the question is asking you how many times, it means it was times. That thing was times by how much to give you the image. So here we found that the first one in number A in rectangle EFG, the scale factor was 2. The second one, EF, line to AB, was 1, which is the scale factor was 1. Right? All right, guys. So I believe by now, guys, we have come to the end of our lesson today. So you guys have been wonderful. It's been a plum, pleasant pleasure as well as a privilege to be with you, grade 7s. And I thank you. Please go through all the things that we talk about I talked about in the video. Pause, do a rewind, re-practice, do them practically. Don't just watch it for the sake of understanding. Watch and do it. Because if you watch and do it, then you'll understand better. I thank you guys. Have yourselves a wonderful day.